about scaling generative AI applications and very specifically agentic AI so that you can create business competitive differentiation for your products. One of the main things that I hear these days is CEOs and CTOs talk to me about how do we infuse Gen AI into our products. Uh, Board members are telling their CEOs, we need to infuse Gen AI in some shape or form to differentiate our products. And so there are 10 things that we've kind of extracted from experiences in this area. Number one is to identify high impact use cases so that you don't want to, essentially just do things that are of technical value. You want to look for repetitive tasks, content creation needs, areas where creative solutions are needed, but they're resource intensive. And it's a good idea to conduct workshops with department leads so you get everybody's opinions, what their pain points are. And by focusing on these high impact areas first, the business can showcase early successes and build momentum. The second is to build this on a solid data foundation. Because generative AI, if you want to tune the models or provide models with sufficient information about your business, it requires high quality data sets. And of course, a robust infrastructure to run on, to clean the data, gather the data, curate the data, put it in the proper format. And this implies strong data governance practices so you can ensure data quality and accuracy. The third is to foster a very collaborative AI culture so that you have collaboration between AI teams and non-technical teams, departments that are not necessarily into AI, they're in the business of doing the business of the company. And you might conduct training sessions and develop cross-functional teams, open forums where employees can discuss AI ideas and applications. You may want to create what's called an AI champion program across departments that can bridge the gap between the technical and the business folks. Fourth is to create a roadmap with business objectives in mind. So rather than, again, go on science experiments, which are fantastic, but the business will cease to fund them. So you need to align with long-term business objectives and short-term business objectives and define how your AI is going to address the needs of each one of these in the time frame that's given. Fifth, you actually need a scalable AI infrastructure that has solution completeness. Today, a lot of discussion is around models, which is absolutely appropriate. However, AI is much, much bigger than models. You need a lot more to be successful than just the engine of the car. So you need all the components of the car in order to have a successful driving experience. Sixth is to have a program where you're ensuring ethical and responsible use of AI. You want to establish guidelines for ethical use. Many companies, including Google, have responsible AI guidelines and practices that you can take a look at and adapt and adopt appropriately. But it's important to maintain the transparency in your data, maintain privacy in your data, mitigate any bias that may be in your data for minority groups or majority groups, and try to balance it out so that your AI is not being trained or provided with data that disenfranchises a particular minority. Seventh is to have a continuous improvement loop so you get feedback on a regular basis, but you need to do this both technically and in a committee where you're actually receiving the feedback from your dashboards, from your monitoring applications, and so you can improve not only your business, but also plan for what the next steps are so that you can update accordingly and remove any blockers. Eighth is to train and upskill your teams on Gen AI across the board. You want to have employee training programs, both for non-technical and technical practitioners. Ninth is to basically make sure that we're measuring the business impact and communicating the results. You may be doing great work, but if you're not communicating what work you're doing, it goes unnoticed. And therefore, the business may essentially decommission your project. So use a mixture of quantitative and qualitative feedback, like revenue growth, productivity gains on the qualitative side, employee satisfaction, the general sentiment around the quality of the models that they're using to assess the effectiveness of AI. And then report this in a very transparent fashion so that it helps you overcome any kind of barrier and increases and builds stakeholder confidence and trust. Finally, to prototype and experiment early and often. This was definitely true in the earlier stages about 2 years ago, and increasingly so. However, now there are a set of well-established use cases. So what you may want to do is look at those low-hanging fruit and not spend too much time brainstorming around what you need to do. Rather, take a look at what others have done, see if you can do something commensurate with that, and then enhance it. So you want to set up some kind of an AI labs or an innovation hub where employees can actually experiment with generative AI in a controlled environment. And the frequent experimentation allows the organization to identify viable AI applications, learn from its failures, and then rapidly iterate. Now, having said that, it's very important not only to try and infuse AI in these business use cases, but the actual enterprise platform that you use to build your AI is extremely important. So you need enterprise scale AI. Over the past 18 months, we've seen customer adoption increase, and there's first trend is that customer maturity is increasing. There's deep integration into the various industries. People are looking for solution completeness beyond models. Number two, they want interoperability. So platforms that support AI tool integration across the different stages of production. They want optionality and choice. For example, in the Google Model Garden, we have over 150 models that you can choose from the open weight models to Google's 1P models and the third-party proprietary models from our partners. Thirdly, everybody wants to go from POCs into production. They don't want to stay in the same place where you're continuously doing proof of concepts. So some of the use cases, as we analyzed the 185 customer engagements in terms of customer adoption, are represented here on this slide. So they include personalization at scale, augmented creativity, automation of routine tasks, accelerating the innovation cycles by reducing iteration times in product development, R&D, and even drug discovery, all the way to AI-powered decision-making with the help of predictive analytics and data-driven decision-making. And of course, customer-centric virtual agents are at the heart of what people do with generative AI. As we see some of the emerging technical trends for scalable GenAI applications, we're seeing an increasing interest in large context windows. At Google, we have the largest context window available in the industry, up to 2 million tokens of input. We have context caching, which we'll get into soon. We have multimodality, and we have advanced agentic architectures that help you divide and conquer the task you're undertaking. Looking at organizations and how they evolve, we find it convenient to look at this in terms of this maturity model, where at level 0, you're getting your data house in order. Level 1 is you're prompting and serving the models. Level 2, you're performing retrieval augmentation, augmenting the prompt, and then serving the model. Level 3 is your tuning with your own data. And level 4 is providing grounding. The output of the model is then grounded. What that means is, for example, at Google, we have 2 sets of grounding APIs. The output of the model can be grounded or verified or fact-checked by an internet search or a search in your internal documents if you give it permission to do so. And these are API calls in your own secure cloud environment. Level 5 and 6 pertain to different levels of agentic systems. Level 5 is a multi-agent system that's basically one LLM calling multiple agents using function calls. Level 6 is more autonomous agents that can orchestrate together. You can think of level 5 as the orchestrator or a director of a classical orchestra, and you can think of level 6 as basically doing more of a jazz band where everybody needs to coordinate with one another. And of course, evaluation and observability and LLM ops becomes critically important at every stage. So one of the things that I think is very, very important is to understand the vectors of competitive differentiation. And these vectors of competitive differentiation are essentially as follows. Number one, we talked about the data provenance. Where's the data coming from? Who manipulated the data? How is it provided to the language model? These are all capabilities that can help you tune the model. So from there, bring that back. Okay, there we go. So the next thing is to prompt the models using Gemini's industry-leading 2 million context window. This allows for in-context learning. You get less hallucination and less cost for fine-tuning, for example. We just announced Gemini 2.0 Flash, which offers 2 times the speed of Gemini 1.5 Pro, a stronger performance in terms of multimodality, which includes text, code, video, spatial understanding, and reasoning. This is announced as an experimental model right now, and we have in GA Gemini 1.5 Flash and Pro. We also have our Gemma models, which are available as open weight models. Imagine 3 on Vertex allows you to generate text to image of very high quality. It allows you to edit and customize those images. You could obviously create images from prompts in seconds using Imagine. This helps in product marketing, generating product descriptions and brochures, etc. We also have a capability to generate video of up to 6 seconds with a resolution of 720 pixels and a up to 30 frames per second. So check out Veo on Vertex AI, which can help you generate video for your marketing and capabilities to generate short clips in any style. Generated content could be, of any style and shape as shown here. In terms of the analysts, Google is a leader in the Forrester Wave for foundation models. We lead the pack basically, and we're top of the leaderboard most weeks, if you will. However, there's more to what we're talking about in terms of capabilities for AI. They include ML ops and the ability to have feature stores, tuning of prompts, management of prompts, monitoring of models, and evaluating results of services. Retrieval augmentation, I'm not going to go into. Everybody pretty much knows that. You're retrieving information, adding it to the prompt, then sending it to the language model. There are various techniques that cover a spectrum from very basic naive RAG to self-corrective RAG and advanced RAG, which they're very capable tools for this process. Fine-tuning is a very important element of adapting a model to what you need. And in fact, I'm going to cite a Stanford research paper in May of this year called Many Shot in Context Learning in Multimodal Foundation Models. So what this study showed is that they tested zero shot, few shot, giving a few examples, and the many shot was essentially about 2,000 examples in the very large context window. And the results that were there indicate that it was comparing Gemini 1.5 Pro and GPT-4 Omni, the blue one being Gemini 1.5 Pro. And so with that, what you can see is essentially the fact that with Gemini Pro, as you increase the number of examples, the model gets better and better in a very consistent fashion. While with the other models, you can see that there is erratic behavior and lack of stability as you start to give it more and more examples. So in order to help this along, we have context caching that we've announced quite some time ago. What context caching does is it allows you to provide your prompts and if you have a very large context window, let's say you're giving 2,000 examples, you only pay for it once in the context window, and you can cache it the rest of the time. So it's effectively you're paying for storage costs from then on, not input tokens to a language model. So this enables you to cut costs dramatically and yet at the same time leverage that large context window. You can optimize it because we have a batch API, and you can generate JSON or XML outputs as well. So serving the model, we talked about that. We have over 150 models in the model garden with various different models. Our first-party Gemini models, our smaller models that are open weight models called Gemma. And these open weight models are very specialized. You have CodeGemma that does code generation. You have PalyGemma for generating outputs that are visual. Gemma 2 is a general purpose one, and we have a time series model called Times FM. We also have a data Gemma model, which does what's called retrieval interleave generation. So what it does is essentially it generates a query in the midst of generating an output. So it will go to a database and retrieve information and insert that in the generated content. This severely decreases hallucination and inaccuracies of the model because it's actually going to a reliable source through a query and bringing information back. And of course, multi-agent systems. We have capabilities for multi-agent systems we call Agent Builder, which is the low-code, no-code, and we have a software development kit for building multi-agent systems. But what are agents? So agents essentially have some goals and directives that are often given as a prompt. These agents have an LLM, kind of like a brain inside of them, and they can sense the environment, whether digital or physical. They can reason based on this sensing and based on the goals given in their local memory. And they can plan and coordinate actions. And then they take actions via tools that they have to interact with the digital or real world. And they can collaborate with one another through shared memory. For more information on this, you can take a look at this QR code, which contains a blog which details this much more explicitly. And therefore, you can create multiple types of agents like customer agents, employee agents, creative agents, etc. And then next is the grounding capability, which is the ability to reduce hallucinations by fact-checking the output of the model, essentially. So we have APIs that provide grounding via Google search and inside of your own secure enclave. So the user essentially makes a request. There is a search capability, and then there's a grounded LLM response that provides a citation and a search entry point. So in terms of evaluation and observability, if you recall, we were talking about being able to do rapid experimentation, evaluation, and monitoring at every aspect of the AI lifecycle for governance and transparency. For example, you can use what we call the auto side-by-side model. And the auto side-by-side lets you compare two models with a given prompt. And then there's an autorator, which allows you to compare the results of these two models and then rate them. Because one of the challenges we run into is that when you change the version of a model, when you change into a new model, your old prompts typically don't work as well. And so you need to fine-tune those prompts, figuratively speaking. You basically need to change the prompts. And this auto side-by-side feature allows you to change the prompts accordingly. Of course, monitoring is extremely important. We have Vertex AI model monitoring, which allows you to look for skew and drift in your models. And then last but not least, we have the LLM ops capabilities to build end-to-end pipelines and access feature stores and be able to do experiments across the lifecycle. This all runs on an AI infrastructure of GPUs and TPUs that we have as part of our infrastructure. But as a last point, I'd like to leave you with a project we call Project Astra from our Google DeepMind, which I think you'll find interesting to watch.
Okay, let's do some tests. Tell me when you see something that makes sound.
I see a speaker, which makes sound.
What is that part of the speaker called?
That is the tweeter. It produces high-frequency sounds.
Give me a creative alliteration about these.
Creative crayons color cheerfully. They certainly craft colorful creations.
What does that part of the code do?
This code defines encryption and decryption functions. It seems to use AESCBC encryption to encode and decode data based on a key and an initialization vector, IV.
That's right. What neighborhood do you think I'm in?
This appears to be the King's Cross area of London. It is known for its railway station and transportation connections.
Do you remember where you saw my glasses?
Yes, I do. Your glasses were on the desk near a red apple.
What can I add here to make this system faster?
Adding a cache between the server and database could improve speed.
What does this remind you of?
Schrodinger's cat.
All right, give me a band name for this duo.
Golden Stripes.
Nice. Thanks, Gemini.
Well, with that, thank you very much for listening to the presentation today. And I hope you will reach out if you have any questions.